She was in pain and I was trying to comfort her and everything. And then I took a piece of paper. As being an engineer, I said, let's sketch an ultrasound bra. So this technology was a dream on a piece of paper, but now it's real.
Your grandfather passed at like 28 years old from heart failure?
I promised myself, I said, when I became 28, I want to do something for heart patients. And it really happened.
You sound like the ultimate Renaissance woman. Well, what a treat it is for me. Dr. Canan Dağdeviren is someone I met in September of this year. We were on a panel together. I don't know what the heck I was doing there. Dr. Canan was on the panel with me at Sages and Scientists, an event that the Chopra Foundation, Deepak Chopra Foundation puts on up in Cambridge. And it was the highlight for me was getting to be on the panel with these wonderful folks. And I came away so impressed after meeting you, Dr. Canan. I just can't wait to learn a little bit more about you, your story, and your interest and how it's manifested itself in the work you do at the MIT Media Labs and MIT more broadly. But tell me, I know you have a new baby, 21 months old, and he's keeping you up at night. But there's other things that have kept you up at night throughout your life, which are more controllable, I guess, than a 21-month-old. But I'd love to hear where you're from and how you began life. Turkish, I know. And I checked out a couple of your interviews, and boy, you speak Turkish beautifully.
Thank you so very much. And thank you for making time to meet me too. And so to tell about myself, I was born in Istanbul and raised there. And then we moved to another little city close to Istanbul called Kocaeli. And I was there till high school. And I have two brothers. And
were you in a birth order?
I am the first one, and I am a product of two individuals who love each other deeply. So I always call myself I'm a love baby, and like my brothers. And in our family, we have been encouraged to ask questions. I think this is the first thing that I learned among many things, many habits in my family. I remember when I was a little kid, I was smashing up rocks to find atoms inside. And everybody was telling me that it's impossible to see. But my father, I think he saw like my compassion, like my passion in science. And he took me to a university where his friend studies, and he introduced me an atomic microscopy, which I had no idea.
I would hope. How old were you then?
I was, I think, around 6 or 7, maybe early. At that time I was not studying. I was not in the school yet, but I was about to. So it was somewhere before the school.
Dr. Canan, I've heard that's a recurring theme in the wonderful people I get to meet and chat with on this podcast. Is the opportunity to get exposure at a young age, particularly when it's your parents seeking out those exposures for you at a very young age. You know, it could just be an interesting person in the community, but the idea of exposing children to thoughts, ideas from elders in areas that may not be their area of interest and knowledge, it seems to be a recurring theme.
I certainly agree, and I'm trying to do the same thing for my little baby and other kids around the world, and specifically for my community, like Turkish young generation. I try to show them through social media what I did, and you can also do it. I want them to resonate in their brains and hearts that they can do that too. As long as you know your main interest. You can be a scientist, you can be a cook, you can be an artist, does not really matter. Only matters is you need to know what you're interested and what you like really doing so. So my exposure to that microscopy, of course, I did not understand what it was, but I was much more interested in the rocks and how they work and all such things. And then my father put me a book in my hands. It was about Madame Curie. I thought I think he thought I would be inspired by Madame Curie. But when I read the book, I fell in love with her husband, Pierre Curie, who discovered an amazing phenomena called piezoelectricity. And it was at that time just a single word for me. I first chopped the word and understand what piezo means, what electricity means as a kid, young kid. But then later on, it became my scientific destiny. I learned more about it towards the end of my college degree.
Now, you talked about the influence your dad had on you, both your parents, but in this case, your dad introducing you to someone he knew at the university. You come from an interesting family, but not a great gene pool from a health point of view.
You're right. Unfortunately, it is the case. I'm high risk. I lost my grandmother, my side, my mom's side, and my aunt because of breast cancer. And my mom has genes. I do have two, and my mom had lumps. And it has not only that. I lost my other aunt because of colon cancer. My granddad because of heart failure. A lot of diseases.
And if I recall, I remember when we met a few months ago. I think your grandfather passed at 28 years old.
Yes,
from
correct.
heart failure.
Yeah. And I did not get to see my grandfather. So I was really little when I learned that he passed away. So, and when I learned about that as a kid, I was very shocked, and I was like, how a person can die in a very young age, and how it happened. And then I learned about heart and what people use when they have when their heart rhythm is not regular. And then I learned about pacemaker, how the pacemaker works, and how the other things function.
This curiosity was early in your education years. This wasn't later on when you decided to pursue a track in the sciences.
Correct.
This is a young curiosity.
This is a very young age. When I learned about my grandfather, I was 6 years old. I still remember that time very vividly. And I was really shocked. And the only thing that I did at that time, I promised myself, I said, when I became 28, I want to do something for heart patients. And it really happened. When I was 28, I designed and developed a device which can be laminated on internal organs like heart, lungs, and diaphragm. And whenever your heart beats, this device can be deformed because it's based on the magical phenomena that Pierre Curie discovered, piezoelectricity, and it can generate current and voltage and can charge your pacemaker. So by the time this invention was realized, I was 28 years old, and I really made my dream came true. And it was recognized by amazing agencies like Forbes, MIT TR35. I got the Illinois Innovation Prize. It was very rewarding, and I not only kept my promise, I also have this device dedicated to my grandfather and people who are suffering because of heart failure. So kind of my research has a personal tone, a very profound personal tone. It's not only science. I'm not just doing science. It's a calling for me. It's not a daily job for me. It's just a part of my life, my lifestyle.
So you go to high school in Turkey?
Yes, I did.
And good education system?
Very good education system. Great in terms of theoretical knowledge. Practical one is a little bit limited, but theoretically, I was very fulfilled during my high school and college degree. Then I got the Fulbright scholarship. I was actually looking for people who can help me to make these devices that I dream of. And I searched a lot in Asia, Europe, America. Then I found my advisor. From an article I was reading when I was in a college, I realized there is a person who's called John Rogers in University of Illinois Urbana-Champaign, and I really wanted to work with him. Then I secured my funding because I really wanted to be financially free to do my dream project, which was this heart failure device that I designed for. And then I got my Fulbright fellowship as being the first person in Turkey in my field to get the PhD scholarship. And came to University of Illinois Urbana-Champaign and had the chance to work with John Rogers.
What an opportunity that was. That must have been a big emotional time for you, though. I mean, leaving your country,
exactly,
leaving your family. It's a beautiful campus, but it's kind of cold there in the wintertime. And I've visited the campus a couple of times. It's like a little city unto itself. Yeah. But you overcame all of those things. You were in pursuit of your dream.
Exactly, and two different worlds. Turkey and Midwest is totally different in terms of everything: landscape, people, culture, food, weather. Everything was new to me, but I enjoyed it. I really put myself in a bubble, and I had a dream that I really wanted to do. But Jim, like first 3 years, nothing worked. Nothing worked.
What do you mean? In your work?
In my work, exactly. Yeah. In my work, in my experiments.
So because you were in this specialized program and you had a mentor that you knew a lot about,
yeah.
You said you put yourself in a bubble. So from a social point of view, from a physical point of view, where you lived and all, was it comfortable right away? Did you feel like this is you belong there?
I think so. I am a type of person who, wherever I go, I can sort of refine and define myself for that position so that I can survive and do my my work if necessary. So I was comfortable. It was not so much discomfort until I realized I am one of the few female students in his group. So it was that gender variation was a little bit, actually not a little bit, profoundly difficult for me. So whenever I asked a question to my male colleagues, I was rarely getting an answer. And theoretically, I knew everything, but not practically at all. So that part was very difficult. But instead of being sad and going back to my home country, I took a chair, sat on it for days, weeks, months, and years to see how people are using their hands, how they are combining their materials, and so on. And throughout this 3 years, I had really deep support from my parents and as well as my mentor and friends who were around me, like international friends, American friends, who really made me to feel home. I feel like after Istanbul, Illinois is my second home. Whenever I go there, I feel it's home for me. I spent my 5 years and I made all my dream projects realize. So they gave me the opportunity and the freedom to do my research. So it's very dear to me, that part of America.
So you got your undergraduate degree there?
No, I had my undergraduate in Ankara, in the capital city of Turkey.
Yep.
Then I got my master's degree from Istanbul in Sabancı University. It's a private university.
So you were in a PhD program, which has a different consequence in terms of your age, maturity, social environment, everything. Was it, were you social there? Were you very involved, or you just had your head down in your work?
I was very social.
I like that smile.
Quite social. First of all, I did one thing which I think worked so well for me. And this is partially why I am comfortable on the stages while giving talks and panels and so on. I enroll in an assembly, music assembly, where I learn how to use my voice and how to use my gestures and how to work collectively with others, especially when you make a sound and in a collectively, in a harmony, a music, you have to work very collectively. So I learn the beauty of collaboration and using your sound and gestures and everything in this assembly, which was very, very rewarding for me. I visited multiple cities all around America and gave concerts, and I exposed myself to the other cities, and I met multiple people from different cultures. So it was
so voice. Do you play instruments as well?
I don't play instruments, but I was told I have good voice. I can sing nicely. Yeah.
Well, we'll take you up on that very soon. Bring in the piano, please. So I'm intrigued by the work you do. I'm trying to get to know more about you, but I'm so interested in the work you do in it. But you sound like the ultimate Renaissance woman. I mean, most people are right brain, left brain. You're one of those rare people who are both left and right.
I try. Yes, I try.
So tell me about the science of your world now. I've read a lot since we met. I've read a lot about you. I listened to a bunch of different lectures you've given, and I'm intrigued by your interest in electrical, chemical, biological, emotional impacts. You seem to be entranced by the body, the human being, and its intricacies. And you talk, one of the programs you've established is all about decoding the signals that come from our body, be they chemical, electrical. And I'm intrigued by that intersection in the sciences that all manifest themselves in the body. Tell us how that curious past, this little girl breaking rocks in Turkey, is now taking that same curiosity and saying, I can measure the body. And of course, I was blown away by the story of how you became interested in what you're most known for at the moment, which is the invention of a bra that women wear that would be decode what the body signals are to detect very, very early through ultrasound potential breast cancers. So I know that you told us at Harvard at that lecture hall about your relationship with your aunt. I think she was in the Netherlands.
Yes. So first of all, you summarized my work very beautifully. Thank you for that. When I was a little kid, I was not only interested in science, but also poetry. When I learned about Rumi, I know, right? So you knew it right away. When I read about Rumi, he had one saying which really resonated with me. He says, "Do not feel lonely. The entire universe is in you." So I really wanted to understand how this universe in my body, what it is all about, and how I can decode the different parts of the body. Like, I believe every parts of our body parts are like talking to each other. They have a biological language: heart, lungs, diaphragm, skin, eyes. But we don't necessarily have right electronic tools to decode this biological language into electrical language. And I think we really needed to do it earnest. We really understand how this translation is like a Google Translate, but with technologies.
Yeah.
So if you make the devices comfortable, which can have the shape of any human parts, then we will carry these devices for a long time on our body and have.
So these are listening devices,
exactly,
which then can take that data and transport it elsewhere, so it can be decoded, analyzed, looking for those relationships, those chemical relationships, those electrical relationships. At some point, is it just energy?
Not only the net energy, I often call them vital signs. So this could be a pressure, this could be a temperature change, or modulus change, how stiff your skin is. For instance, by looking at the stiffness, we can even come up and understand the signatures of your melanoma progress over time. I did the trials, for instance, on patients in Arizona where we have the direct sunlight through these devices. And not only that, you can even do imaging, as you said, the electronic bra that we invented. It's a technology. Currently, for instance, if I have my ultrasonography in Istanbul, my home country, and come back to America and have another ultrasonography, oftentimes, even though I'm the same person, the results differs.
Why?
Because it is operator dependent. They think any operator will have the same scanning speed on the curvilinear parts of the body, and they will have the same pressure on top. And imagine the probe is rigid and your body is soft, and to cover the entire breast tissue, you have to take the images from multiple parts and then stitch them together. And oftentimes when you do this stitching, the errors occurs. So it depends how you stitch them. It depends how much you pressure on them. It depends how much you scan, how speedy you scan this tissue. So I thought, what if we have a universal way? Like a bra, you will wear it, you will sit down, and literally while
How long will you wear that?
Within sub-seconds, you take the entire image of your entire breast tissue. And you don't need an operator. You don't need a cold ultrasound gel. because the technology, given that it is flexible and malleable, this is the beauty of our work, you can cover and have the intimate integration. You can even cover these curves very nicely.
And it adjusts temperature-wise to the body's temperature.
No. What it does, it actually, you apply voltage to this technology and it vibrates that you don't feel, by the way, and it creates sound wave. And the sound wave travels through your tissue, and wherever it comes, it meets with an obstacle like a tumor, lesion or something, that sound reflects back and captured by the device so that you can see the image of those tumor or lesion or any vessels and anything in a black and white image, like we do, when we go to the hospital, we get the similar images, black and white images, which can point to coordination of the tumors and everything. However, the idea is here, how we can make this home-based system, how we can enable frequent screening for women who are high risk, because over 40% of high-risk women develop breast cancer in between two mammography. Mammography is the golden standard, and it's radiative and very painful. And you can't have mammography every other month. You do it like every other 2 years or every other year. By the time you have your second mammography, assuming the first one is clear, over 40% high-risk women develop cancer in between, which is called interval cancer.
And mammography doesn't detect every kind of breast cancer.
Correct. Especially mammography is not functioning well on the denser breast tissue like myself, like individuals who are below 40 years old. So this technology will be an adjunct technology to the current golden standards, but at the same time, it will allow you to frequent screening. And not only the breast. Breast is the start because it was an inspiration from my late aunt who passed away because of breast cancer. And we literally...
Who challenged you.
Who challenged
you on her deathbed.
Exactly. She was in pain. I was lucky to spend her last 12 days with her. She was in pain and I was trying to comfort her and everything. And there was nothing else to do. Like we were like literally waiting her pass away. And it was a miserable time, not only for her, for all of us around her. And then I took a piece of paper. As being an engineer, I said, Aunt, let's sketch an ultrasound bra on it. Like, how do you want this bra to happen? Like, because she had regular breast screening, but she developed the cancer in between two scans. So it was too late for her. And she was giving me feedback while being in pain. And it really ingrained in my brain that moment that I cannot get rid of that. Like, I always remember. And it's for me a lifetime motivation. Like, I am helping other aunts, I'm helping other families, I'm helping other kids who may lost their mom because of the breast cancer. So this technology was a dream on a piece of paper, but now it's real. We spent 6.5, now 7 years on this project. And right now, right here at MIT, we are trying this technology on the other woman's body to understand how we can come up with the specificity, sensitivity of this technology. And the next step would be the translation of this technology. So upcoming year, first half of 2025, I am launching this company to make it even more impactful. With a very humble calculation, we realize this technology has potential to save 12 million lives per year globally. Yeah, it's like multiply with 48, 50 million people. They will have peace of mind because they will know what's happening with their very personal part.
Fast forward 5 years from now, we sit back. You're about to sing a song for us all. We have a glass of wine in hand, and you're thinking about what you've accomplished with this company in the next 5 years. Now, looking back 5 years from now. What's happened? Is this available universally around the country, around the world? Is this replacing mammography? Is it supplemental? What's happened in these 5 years?
I am so big fan of Cologuard adventure. I'm not sure if you know about the Cologuard, that you have a piece of stool in the vial and it's sent to the doctor, and then they let you the possibility of your being having a colon cancer, or you should have a colonoscopy. So I see my technology along the same line. It will not replace the mammography. It should not replace the mammography, whereas it's an adjunct technology to the mammography. It's kind of an empowering mammography results by having an additional technology that you can do at home.
Would this have to be prescriptive or not necessarily?
Yes, it has to be prescriptive. And I would love this technology. For instance, during COVID, we lost more women because of the barriers to the hospitals. They couldn't have the scanning, they couldn't have the diagnosis, and so on. So I told this technology, like a phone, like every woman, every man, everyone has a phone. But if you also have a bra which can check your very sensitive tissue, which is your breast, it's the number one cancer type among women. I would love to have one. I would love to gift one to my loved ones, and so on. But most importantly, we are privileged. We have insurance. We don't have barriers for hospitals and so on. But many women have barriers for this kind of sophisticated technologies. I specifically would love to have my technologies to be used in rural areas where women don't have
same access.
Exactly, same access. And for instance, we have a lot of problem with the data too. Like, data will be the second product. We still have no understanding why the number of breast cancer patients is low in the Black or Hispanic communities. It's not only because of the genes and so on, because they also have barriers. They are not screened as frequent as the white or more privileged communities. We need to make this technology more democratized for everyone.
So tell us about the cost.
You
have the cost of the product itself, and then what about data capture, repository, and analysis?
Yes. Currently, what I am working on right now with MIT Sloan, the business school, in addition to the technology, how the pricing should be. So we are now coming up with the business model. If we should pay upfront, or how we can get reimbursement through the insurance companies. We're also talking with the insurance companies. But the cost would be cheaper than an iPhone, cheaper than your smartphone. And you can use this for over 4 to 5 years. And one scan will cost less than a cup of coffee compared to $2,000 that we do at hospitals. So it's a win-win-win situation. Win for insurance companies, win for patients, win for doctors. And with our calculation, again, with the MIT Sloan, is that the medical breast screening spendings only in 2020 is $30 billion, and it's increasing every single year by 30%. And with this technology, we will also deduct the medical cost by half, like almost $15, $16, $17 billion every single year.
What an enormous impact you're going to have on everyone.
Yes, it is. Yeah, exactly. It's good for everyone. When I think about the impact, not only on the patients and family, but also the doctors, imagine there will be less traffic at hospital. They can spend more time on other more devastating cases and diseases. They can increase their KPI. They can be more happy. Like, if the doctors are happy, they can function more better. Like, people will be in general will be more happy. And I really trust in the versatility of this technology. I had my baby around 20 months ago, and I'm a petite woman. You saw me on the stage, but my baby was big, very big. And he had a hard time to move in my belly. And all the time when I had ultrasonography, I was in pain because they were really pressing against my body. And at some point when I was at home, I was not sure if my baby was really moving. And I could not go to hospital and have ultrasonography all the time. But what I did, I took that patch and put on my belly, and I watched my baby. Like this technology, not only for breast, it can go as deep as 15, 20 centimeter depth in the body. You can watch your pancreas. You can watch your kidney. You can watch your baby. You can check your bones. You can even use this technology in outer space to see when the bone reduction is happening on astronauts. We still don't have no idea how the health of the astronauts in the outer space and how it can be a kind of a baseline for us to understand the bone reduction on elderly patients. So the applications are limitless, but of course we will start with breast and then move on hopefully with the other ones.
Well, it's so exciting. All the resources you have there at MIT with the Media Lab, with the science world you live in, with the business school next door, exciting for you to be able to pull all these things together. Mm-hmm. And we're going to want to watch you, cheer for you, fund you, and just keep track of all the great things you're doing. But in that collection of great things you're doing, beyond ultrasound, your curiosity about the human body. Tell us where you talked about, I know you've been doing a lot of work in something that I'm keenly interested in, and that is the world of Parkinson's. Mm-hmm. So you have nerve communications, you have cellular communications. You talk about ingestibles, implantables, wearables. It seems like we're at the very beginning of a new age of science in terms of how we detect, treat, because you talk about in some of your work about the impact of an oral drug on let's say a Parkinson's patient whose the dosing is so, because it's taken orally, is so inaccurate, and it has a manifest impact on the rest of the body beyond the places it's intended to influence. What's going on in the science of those measurabilities? There's a doctor here, a research doctor here in Long Island where I live. His name is Dr. Kevin Tracy, and he does a lot of work on the vagus nerve. And he thinks that's the epicenter of everything that's going on in our body, deliberate and passive. So you talk about, so you have interest in chemistry and biology and electricity, all of which manifests itself in the body. So how did you get so smart about so many things?
I think I will come back to music again. So, like you are working in an assembly and with having different tones of the music and put them together in a harmony to make a song to give pleasure to people who are listening to, it's the same. For body, what I am thinking, yes, I study breast, I may study brain, but not necessarily I know the communication in between. For instance, we say the gut is the second brain, right?
Yes.
There was a study from Harvard.
And I'm, as a bystander, hearing more and more about gut health.
Yes.
And this past year has been a journey for me, learning more about our bodies and it's something, the next time we get the chat, I'd love to hear your thoughts about, you're involved in detection and remediation.
Yes.
How do you think about prevention? And there's a few doctors I follow who have just beat into my head on my own consumption, the impact that sugars are having on our bodies and what diet and its relationship to our health is. You hear about it, but I've been reading more and learning more about it this year, and I'm sure you have some strong points of view there because you're dealing with the results of our behaviors.
Right. So, for instance, the devices that you listed, ingestible, which goes into your stomach, implantable in the brain, and as well as wearable on your knee. So this is, for instance, right now what we are trying to understand. How and why throughout the medication, some people freeze, some people fell down, some people have tremors. We cannot understand and came to a conclusion by just looking at one single organ. We have to look at the connections between the organ, how my gut motility is changing with the neuronal activity of my deep brain through an implantable device. And at the same time, how I can track my physical ability with a wearable device on my knee so that I can understand, maybe to your point, maybe I even don't need to do any intervention. Maybe just visualization would be enough. For instance, I take a drug, right? I have Parkinson's disease. I took a medicine and I visualized my brain activity. And I realized that my brain activity is not, is a desired location. Then what I would do, I will take more drug, right? And then if I take more drug, then I can see the change in my motility, in my GI tract, and vice versa. I can see my gait quality through a wearable device on my knee. Maybe by doing more physical activity, I can alter my brain activity and through that to my motility in my brain so that I don't need to take more drugs unnecessarily. So I can even make personalized drug regimen by checking the connections in 3 organs. There have to be a balance.
And does that trigger the dosing internally, electrically?
Electrically, exactly, electrically and chemically in the brain. What we do in the brain, we not only check the neuronal activity in between the neurons, we also infuse drugs like dopamine or muscimol to that special location in the brain, which is called substantia nigra, so that we can see the behavior. Right now, we don't try on animal models, human models, human subjects yet, but the animal models. For instance, we can even alter the behavior within sub-seconds because we are in the deep brain. We can make an animal to turn right or left, stop and run by just sending a simple code through our computer wirelessly. And with that, we can even see their gait motility. So what I am coming to is there is a way, I strongly believe that if we can understand and decode the underlying mechanisms of the Parkinson's disease physically and electrically, then maybe chemical interventions will be even less and less, so that we can get less systemic toxicity in our body. And in junction to that, I am also very interested nowadays the pain management. There is no way that we can categorize and measure the pain. There is no way. There is no technology, nothing. When we go to doctor, they say from 10, just say, how is your feeling? 4, 5, whatever. However, we have to have an objective way to measure the pain so that we don't necessarily get tons of drugs in our body, or we can treat majority of the diseases by having an objective measurement on pain.
So is the science getting close enough that you'll be able to have an empirical measurement of pain?
This is what we are trying here in my group. Yes, we just started that.
And might that pain be managed in the future non-chemically?
This is what I am hoping to do.
Wow.
Or maybe I should say less chemically, much less chemically, or very much personalized. We always get ibuprofen or other different types of painkillers when we have headache or muscle headache and whatever. But Jim, you are different and I'm different. And most of the time we might get the same dose, but it shouldn't work the same way that it works on you and me. We should have a much cleverer way in this 21st century.
And what about administering that? So the dosage should be different. 3 times your size. I shouldn't be taking the same dosage as you. Is there a way to get that medication into my system other than orally or other than an injection?
Your questions is so timely. So we are also working on a patch which is assisted with ultrasonography. And what it does, you laminate it, for instance, on your abdominal skin or on your face, on your arm. What it does with the drug reservoir underneath, the ultrasound vibrates and creates bubbles. And at a resonance frequency, these bubbles burst and creates an injection through your skin. Skin is the largest organ and we have porous. And non-invasively, yes, you create temporary porous structure on your skin, which makes these drugs to be absorbed 26 times higher than the other technologies can provide, including needles. And we publish it actually.
And so much safer.
It is so much safer, so much adjustable. Especially imagine for women who are going through IVF process, a lot of needles on their belly. They don't need to do that. We can have this technology as an ultrasound-assisted patch on your abdominal skin for different types of hormonal delivery. At the moment, we are doing the hormonal delivery, not necessarily the pain drugs, but we are hoping to publish this and make it public so that other research communities can take it and use it in the other type of drugs and applications.
But it's people like you who are multidisciplinary, who drawing, and the fact that you're an engineer and a scientist of other crafts within the science world is where I think really interesting things. And your interest in ultrasound, your interest in energy, I've heard you speak about as we move throughout the day, our bodies are creating energy.
Yes.
Why don't we harness that energy in different ways? If you're walking, you're burning fuel and you're creating energy, but we don't harness that energy to be beneficial to the devices we might be wearing for the decoding.
Right. Actually, right now we are almost about to finish that device. It's a technology that you can laminate on your knee, like the most curved location of your body, most bendable place. And you not only generate a lot of power, but also we try to use it to understand throughout the medication how the Parkinson's disease is evolving. There is no way, for instance, what you do usually, you take drugs, doctor asks you to go home, take the drugs, and then come and tell the symptoms. Hey, did you freeze? Did something happen? Did you fall down? And all such things. But not necessarily you may tell these things very objectively. But with our non-invasive technology, which can be worn on your knee, self-powered through your daily activity, like you already self-powered.
You don't need an external power source.
Exactly. You don't need an external power. And you, with no needing a power, you are also measuring your gait quality, the quality of how you walk, the quality of how you freeze, the quality of how you sleep, and all such things. So this is good for human beings, but this is also good for the animals, because especially for I try to think with multi-dimensional, and we work with animals, and I really want to use less animals to save the lives of this amazing species who are helping the entire humanity. So when I talk about this gait quality, I also want these devices to be used by animals so that maybe not necessarily neurologically, but physically, we can also understand the underlying mechanisms of Parkinson's disease so that we don't need to do too much interventions in their brains, but on their body, non-invasively. So these are also different technologies to create different animal protocols when it comes to the experimental explorations.
All right. We can't go any further without the term AI coming up.
Oh,
so
yeah.
We've been 48 minutes chatting and we haven't said AI yet. Okay, let's remedy that.
Okay, let's do that.
I remember visiting with a really bright friend. His name is Bill Gross. He's a great investor, thinker, inventor, and he has a company called Idea Lab, and they're in Pasadena, California. And I visited him, I'm going to guess it was close to 25, 23 years ago in that time frame. And he said, one day, Jim, we'll take off our watches at the end of the day and we'll put them in a little tray on top of our dresser when we're getting ready for bed. And it will download all our bio information from the day and it'll be sent to a database. This is 25 years ago. And I'm thinking, well, that's all come true. Yeah. It sounds to me like you must be very anxious about the fact that when you get up in the morning, there's so much to do. Give us a hint at where you think your journey and your community's journey on wearables, decoding, detection, where might we be a few years from now and maybe more than a few years from now?
What I would how I am seeing my technology, especially if I just give a specific examples among all the devices that we develop, the breast cancer one, I would like, in 5 years, this device will be available and people will be gifting this for Christmas gift to their loved ones.
So I guess 1-800-Flowers has to have another collection of gifts available.
Exactly. And another thing that it's really so much cultural, and I really believe in it, is helping others. So in Turkey, we have a phrase called bread on the hook. So you go to a bakery and you buy a loaf of bread And you also put a bread on the hook so that a person who doesn't have enough money can go and check the bread on the hook and get it.
No, that's interesting.
So I am hoping a concept like bra on the hook. I may buy one myself, and I may also one more and put on the hook. And anyone who may need it, come to my company and say, I need it, but I don't have money. Do you have any on the hook? So that I can give them one. So in 5 years, this will happen too.
I see the name of your next book, On the Hook.
On the hook. And I also see, Jim, is that given that we didn't touch base on AI, yes, the bra is a product, but the data that we are going to get through this device will be another product. We need this data. We need the data coming from woman's body. Currently, we have 265 breast cancer drug lines, but we don't necessarily know the real efficacy of these drugs. What if we collaborate with pharmaceutical companies who are working on breast cancer drugs, and we can do partnership with them? And in real time, throughout the medication, we can see how the tumors, how the lesions are changing real time, and then tell them, hey, you may want to increase the dosage of these drugs, or you may want to decrease this. Again, it's the same thing. I may given the same drug like your daughter or wife are given, but we are different people. So in this 21st century, there should be a clever way to do personalized medicine, personalized treatments. And to do so, we really need a second scheme. I call it second scheme. The devices which can be laminated on our biological scheme and can blend and work with you. It doesn't discomfort you. You wear it. I used to wear sports shoes because it's comfortable. It's the same thing. If the device is comfortable, I'm going to wear it for a long time. If I'm going to wear it for a long time, I will get tons of data. And through AI, I can even predict what will happen in 3 months to my body. So
the big drivers of our behavior are comfort and convenience. And you want both.
Yes, exactly. You captured it so well. Yes. And affordability. I want it to be affordable. I really want it to be affordable. Affordable either through business model or really with the price itself.
Dr. Canan, our community, when they get to know you now, they're going to want to support you and the work that you and your teams are doing. How can they think about doing that?
One thing that I just launched a new council at the MIT Media Lab. It's called Women's Health Council, WHX. They can definitely check the website under the Media Lab website, or they can check my group website called conformabledecoders.media.mit.edu, or they can simply type my name on Google, find my email address, and email me, canand@mit.edu. And we would love to have any support, all the way from clinical trials to intellectual support, to networking support, financial support, any support. If people would like to be a part of this journey, I would love to work with them.
And you're so nice, and you're so charming, and you dumb it down that even I can somewhat keep up with you and understand what you're doing. I'm so happy that Shumaka and Deepak invited me to come up there, because I met these wonderful people on the panel, and I especially had the opportunity to meet you and get to know you, and now have an excuse to talk to you and learn about your world and all the things that you're doing. What's it like? Your husband must be very strong egoed.
He is. He tries. Sometimes he complains a lot because I am really busy, but we are trying to manage the things as much as we can. But he's a great supporter. He's really.
And what's your little boy's name?
Taiga. Taiga means the largest forest on the universe. So it's all the way from Japan to Russia and Northern Europe and Northern America.
How often do you get back to Turkey?
I was there just 2 weeks ago. I was awarded with an amazing Science Prize. It's called Aziz Sancar Science Prize. Aziz Sancar is the first Turkish Nobel Prize winner in chemistry. He lives in he studies in University of Colorado. Not Colorado, I'm sorry. North Carolina University. And he's very influential. So the Ministry of Health of Turkey named an award after his name. And this is the 10th time they are given. And first time ever, it's given to a female researcher. And first time ever, it's given to a junior faculty, which was very memorable and historic day for me. And I was there for a week, attend the ceremony and met amazing people.
How wonderful, and congratulations.
Thank
I know it was richly deserved.
Thank you. Appreciate
you
it.
said the first Nobel Prize winner. I'll be posting this recording when the next one is awarded to you.
Oh, thank you.
What's next for you in the next few months? What are you hot on? What other projects are you going to be working on?
Mostly, we will be doing intensive human trials with this technology. So we just set up our meetings with our breast cancer surgeons at the MGH. So we do a lot of partnership with them. And we have tens of patients coming here. And there are too many details which I even didn't talk about. So we are even guiding patients how to wear these devices nicely through an computer interface. The computer is actually talking to you to teach you how to wear, how to move, what to do. It's very lovely interface. I wish one day you could come in and you could see all these things with your loved ones.
Oh, I can't wait to do that.
Okay, wonderful,
and expose your work to our community here. This has been so much fun, so interesting.
Nice.
You're terrific. Thanks for being generous with your time. I can't wait for the new book to come out. On the hook. We'll be in touch. A lot of people are going to want to follow you, and I want to be the president of the New York chapter of your fan club.
Thank you, Jim. Thank you so very much. And I appreciate your time too. And Happy New Year.